Hey, petrol-like movement, are you interested in that? To make game objects move back and forth between a set of points. There are a lot of tutorials that handle going back and forth between 2 points, A and B and A and B and A and B again. But in this script that we'll be making today, we'll make it so that we can insert as many points, position points as you want. So for instance, you can add 4 positions, A, B, C, and D, and then it will go through them all in order, A, B, C, D, and then start over again, A, B, C, D. But we will also add additional features, such as that you can choose what starting position you want to have. So let's say we have these 4 positions, and you set that you want to start at C, then it will become C, D, A, B, and then so on. And we will also add a feature to be able to choose the direction. So if we choose negative direction and we start at C, it will be CBAD, CBAD. And additionally, lastly, we will add a feature to make it reverse instead of going round and round. So if we start at A, then it will be A, B, C, D, CBA, B, C, D, and so on, instead of A, B, C, D, A, B, C. So let's get started. Let's jump into Unity. And for this, I'm going to use 2 sprites from this platform game assets. It's a free asset provided. You can find it in the Unity asset store. So let's start by making a moving platform. So let's take the sprite, move it out, set it to the tiled, and then change the size to 3. Alright, and just for the sake of it, we will be adding rigid body and a collider. It won't do anything in this tutorial, but if your goal with this tutorial is to be able to do a moving platform, then I will show you all the steps. Box collider. You see the box collider will only cover the first box, the initial box size. We need to set the size of the box collider to the same as the right renderer. So set it to 3. Now, alright. Now we just go ahead and create a script. We can call it mover. Go inside. We'll start by removing all of these. And to begin with, we will be needing a few variables. So let's set serialized field and private transform a target. This will be the target is the game object that we want to move. And we can make another serialized field. Private transform an array of move positions. So this will be all of the positions that our target will move through. And then one last for now, which will be the move speed. Float move speed. Let's initialize it to 5 for now. Great. Now we can move back into Unity and set all of those variables. So let's first go to our GrassGIF and create an empty game object. Move it out and make this a child of the new game object instead. Let's call this the platform. This will be the object that has the script attached to it, and this will be the target that we will be moving. So we do this, we child it to this just to get a better structure in our hierarchy. And here we can create additional empty positions, game objects that will represent the positions that we want our object to move through. So let's create perhaps 3 to begin with. Position 2 and position 3. Let's move this one a bit to the left. Let's move this one a bit to the right. And move this one a bit down. Now it should be moving like a triangle when we are done. All right. Set the script to the platform object. And on the target position, we set what we want to move. In this case, the object with the sprite and collider and everything. Then we set these positions into the array of positions, like so. All right, let's go back into into the script. Let's create the update method. So we want to move the target by using a lerp. So we set target.position is equal to vector2.lerp. And lerp is something that moves. Yeah, it says here what it does. It linearly interpolates between vectors A and B. So A and B, first position, second position, and by t, a percent. So let's start with the first position, which will be move positions.0.position, move positions to 1.position, and then a position. This position is a percentage. It goes from 0 to 1. So when it's 0, we are at this position. When it's 1, we are here. And if it's 0.5, we are in the middle. So we need somehow to determine what the position will be. So let's set the position. We need to create a variable for it first. Private float position, and initialize it to 0. Position is plus equals time.delta time first, because we want it to vary in time, and then times move speed. But this isn't quite everything, because percentages are unitless, so what we feed here should be a unitless variable. At the moment, position is as a time times a speed, so it becomes seconds times meter per seconds, which in the end becomes meters. So this is a distance. So we need to make position unitless, so we need to divide this by something that has a unit of meters. So let's divide it by distance, the distance between this and this. If we don't add this part, then the target will move with different speeds depending on how far these positions are from each other. And we don't want that. We want the constant speed of move speed. So we're adding distance. Let's create it. Private float distance. Now we need to find the distance. So we can do it in the awake. Distance is equal to vector2.distance, and then we feed it the two arrays, the two move positions again, like that. Now we have a distance, and we will move through them. Okay, shall we see what we have so far? What we expect now is that the platform moves from point A to point B, and nothing else should happen because we haven't implemented anymore. And yes, we can see that it does that. So what is the next step? The next step is to change these hard-coded values into something that is more dynamic. So let's create a few more variables. Private int start index and private int next index. So this will determine where we are at the moment, and this is determining where we are going at the moment. So these will change over time as we are going through these positions. So for now, let's just put start index here and next index here. And the same for this one, start index, next index. Now we have to determine what these are. So for now we can just hardcode them again at the beginning. And then we want to know when we are supposed to change these indexes. Well, when we are at position equal to 1, we know we have reached the destination, the next index. So we can check for that. If position equal larger than or equal to 1, then we should change destination. So now we know we have reached this position, so we need to know where to go next. Let's create this one. Okay, and what will this be doing? Well, the first thing we need to do is reset the position to 0 so that we start over again. The next thing, we need to find our next destination. Set next destination index. And lastly, we also need to get the distance. Let's move distance so that we can adjust our speed. Let's create these two methods. Okay, we can start with the set next destination index. What this will do is get a new index for where we are going. And this will be done by setting the start index into the next index. So we're moving the start index to where we are. And then we set next index is equal to the start index plus 1. So we had to increment our start index. And then if we do just this, we will get an array out of bounds when you get to the end. So we also need to take modulus of the move positions dot length. This will make us begin again from 0 when we go up beyond the length of the move position. Okay, that's it for now. And now we need to set the move distance. So this we can do just as we did here. Copy paste it here. And then now we have copied, so now we can remove this and take set move distance instead. Do not repeat code. Alright, now we can try this out and see what happens. Now we should see the platform going around forever in the triangle that we created. You see? Perfect. It goes from A, B, C, and then starts over again from A, B, C. Okay. So the next thing we want to make now is the ability to make it go in reverse and that we can choose the direction. Let's create a few more variables. First one, serialize field, private int direction. I set it to default 1. This will determine if you're going forward or backward -1. And then we have a serialize field, private bool reverse equals to false. If this is true, then we will go, instead of going ABC, ABC, we will go ABC, BA, ABC. We can start with the reverse ability. So let's go to set next destination, and the first thing we do here before setting the start index and next index is to check if reverse is activated. If reverse is activated, then we need to determine what direction we are to move in. Direction. Let's create this method. So let's move it down. Okay, and this direction we need to check if we are at one of the endpoints. So at the moment our endpoints are 0, index 0, and index move length dot length, move position dot length. So if next index is equal to 0, or next index is equal to move positions dot length minus 1. Then we know that we are in an end position. Then we should take our direction times equal minus 1 to toggle it around. Okay, and now we need to change a few more things here. Before we had +1 here for next index, which taking this 1 and change it into direction instead. And we also need to adjust for going backwards past the 0 mark. So if we if we are on a 0 index and we're going backward direction, then the next index will be -1, but we don't want that. We want to start over from the end point instead. So let's go into the set next destination index and check for that. If next index is less than 0, then we want next index to be plus equal to move positions.length instead. This makes us go to the end of the array again. So let's try it out in the Unity. It still goes around as we wanted, and then if we press reverse, yes, you can see that when we getting to the endpoints, which is this one and this one, it goes the other way around. So we're going back and forth now. A, B, C, B, A, B, C. Just like we wanted, right? Okay, let's move back into the code and get the rest fixed. Now we can start to implement the direction, manually setting the direction, and also manually setting the start position. So let's create a new field, serialize field private int start. This will determine which platform is our start endpoint. So it's not the same as this one. This will not change. Then we need to also, from the start, determine which is our end position. And so now we don't need any more variables for this. So let's implement start in our code. At the awake method, let's set start. We can give it the default variable of 0. Let's set start index equal to start to begin with, instead of hard coding it to 0. And then next index, we need to give it a start index to begin with. So let's set this to start index. So now when we have done this, we need to change something down here, just so that we remember it. In this check for reverse, we also need to check that the start index is not equal to the next index. This is only true the first time. If we don't check this, then the reverse will happen immediately instead of going around a lap first and then starting. Okay, so now that that's fixed, let's determine what our endpoint should be. So we need to determine what this endpoint is based on what we gave it as a start point. Determine endpoint. Let's create the method, move it a bit down. Okay, and this one will only check if where end is equal to start, the start position, plus the move position dot length, and then minus direction. And then finally modulus move positions dot length. Writing it in this way, it will consider both the reverse direction and the straightforward direction. So let's go into Unity and I will show you what this does. If this, for instance, set the start element to 1, start index, then the end, if you're going in the normal direction, then the endpoint should be 0. So we're going this to this and then back to this, and then we should go back. If it's instead setting it, if it's still setting it to the 1, but we're going in the negative direction, then it should be this one that is the endpoint. And that is what this line here takes care of. Okay, now that we have our start and end, we should change a few things. For instance, we need to change this. Now our endpoint is not always the 0, it is start, and our end position is not move positions at length -1 anymore, it is the end. Like this. And with that, I think we're done. We can move into Unity and check if it works. Well, it still works as before. If we reverse it, you can see it goes back and forth still. Alright. If we reverse the direction, it should move counterclockwise. Yes, and we can still reverse. Yep. And also notice that if I press the reverse when it's here, it will go back and forth between these two only, and it's because this is still the start position and this is still the end position. But this will never occur in the game because you won't be changing this during your play probably. But just so you know that this will happen if you activate reverse when it's between the endpoint and the start point. Okay, let's try to set the start position. Let's restructure this a bit and move this here. I think that looks a bit better, more natural. All right, let's change the start position to 1. Then we should see it start over here and go as it did before. Oh, the direction is set to negative. Yes, it is. So it goes counterclockwise. And now, let's see here. If we have set the start position to 1 and we have counterclockwise, then the end position should be 2, this one. So if we activate reverse, it should go between this one and this one. Alright, you can see everything seems to work now. The only thing we have left now is to make some damage control. So at the moment we are not having any checks for what the user put in as a direction or as a start. So this can be, if we set too high number here or negative numbers, we haven't got any checks for that, so we will get array out of bounds. So let's get those checks. So restrict start index and restrict direction. Let's create these methods. There you go, and there you go. Change the order of them just to make it the same order as we are calling them. I like to keep a from up and to down structure. Restrict this should only check if our start is larger than move positions dot length -1, then we can set it to start equals to move positions dot length -1. So we're setting it, if it's too great, we're setting it to the last value in our array. Else, if it is too small, if start is less than 0, then we set it to the first value instead. Start equals to 0. Like that. Now we have restricted our start index. Now let's do the same with our direction. If direction is larger than or equal to 0, then we set it to 1. So if we have put in 0 as the direction, then we change it to 1. And if we have set it to big, then we still set it to 1. So this will be, in our case, clockwise direction. Else, if direction is less than 0, then we set it direction equals to -1. Yeah, it's not harder than that. Let's get this, and oh, this should be a semicolon. Oh, and we can move these to below the update method. Okay, and then one final thing that we have missed to do, we should be doing, is that in this arbitrary method, we need to call set next destination index, because at the moment we are setting the start index and next index to the same thing. So we're getting here, this will run first, and then we will instantly get position equals to 1, and then we will run this. But it's better to run this here before we are doing this code. Let's do that and go back into Unity and try it out one last time. Now we can experiment with the move speeds as well and check if it works. You can see that if we are increasing the move speed, it will work. If we uncheck reverse, it will go round. If we change direction manually, it will change the direction. And if we set the start position to 3, which we don't have, it will use 2 instead, but it won't here because that's a check that we're doing in the awake method, and this isn't really the way we should be changing the start position anyway, only before the game has started. So if we set it to 3, we will see that it changes down to 2. Yes, and it goes from 3 and to 0, or 2 to 0. Exactly as you wanted. And if we uncheck reverse, it goes round and round. And if we are changing direction again and having reverse, it goes the other way around. Still back and forth between these 2 points. Great. And the good thing with this is that you don't only need to use it on platforms, you can use it on anything, on enemies to make them patrol, or on, yeah, for instance this saw here. Let's create this one here. Let's make it like we did before, create empty, move it inside, add the script to the game object, and we can use the same positions as we did for the grass. Let's pull them in here, 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 and then we can go back to 2 before we're doing. So now we have 4 in this saw blade. Then we need to add target, so the target is the saw. The reason we're having this target is to keep the structure as I said, but if we would have the saw here and then attach the positions to the saw instead to get the structure that way, well, then the positions would be childs to the saw and move according to the saw. So we don't want the positions to move, so we have to do it this way. Alright, and if we press play, we should see the saw moving as well. You can see saw is moving in the same, on the same positions as this one. And the good thing about this is that it will work for 3D games as well. The only thing you need to do is change the vector 2s into vector 3s, and it should be good to go. Alright, I hope you enjoyed this, and I hope you find this useful, and I guess I will see you next time. Bye bye.